Okay, so the very first thing that we looked at last trimester that we said would overlap was slope. Okay, we said we could calculate slope from multiple different formats being presented to us. Okay, so try and dig deep in your brain. What were some ways that we could find slope? Rise over run. So if we were given something like rise over run, okay, that was a way to find slope. This is the way we typically think about slope when we are given a graph. Now, I can't draw a perfect line, so I'm going to have to make some points on here. But remember, it's always our job when we are calculating slope from a line to find two good points, right? We want to locate points that we know exactly where they are at on the coordinate plane. What is the name of this point right here? What's the ordered pair that names this point? You're correct, it is on the y-axis, but what is the name of this ordered pair? 0, 2. 0, 2? We agree with that? We're going to talk more about that. That didn't go so well for us on the final exam. That's the point 0, 2. What is the name of this point right here?
-1. 2, -1.
2, -1, right? Because it's x comma y, which is really confusing. Girls, we get to blame boys for this. I blame boys for all of it because girls weren't allowed to do math when these things were being created. So boys decided that we would do x comma y, but slope is y over x. Okay, so it's sort of easy to get those flip-flopped, but we shouldn't. So if we want to count rise over run, how do we do that once we have these two good points? What do we do next? I think Sherry has a thought, but she doesn't want to say it. What do you think? So we could name the points. That is exactly right, but you are doing something else with your hand. Why are we doing this? You don't know? What do we think? Abby maybe has a thought?
That's how you find the slope, right?
What do we do with that? What does that mean? What am I don't want to fill in. I'm not going to fill in any info. What would you do if you were going to say, Mrs. McKinney, you don't know how to find slope. You're a crazy person. You forget math. Here's how you're going to find slope here. What would you tell me to do?
Don't you do like, you count how many are this way and then up?
Right, so we're counting how many we have to rise and how many we have to run to get from one point to the other. So you'll quickly learn Mrs. McKinney is weird. It's fine. I own it. I always give the idea of going to a hotel and going to your hotel room. So you're standing right here. You're going to get in the elevator to get in your hotel room. How many floors do you have to go up? Well, we go up 1, 2, 3. Okay, then we get off the elevator, and then what do? We go down the hallway. How many rooms? 1, 2. Now, we went left. What does it mean if we go left? Make it negative. Now, if you counted down and then right, that would be fine. You'd get the same number. So we would say that this has a slope of what number goes on top? 3. What number goes on bottom? And what would maybe be a better way to write this? Yup. Either this or this. That negative in the denominator isn't something we really like. I wouldn't count you wrong. Mathematically speaking, you would be fine. That negative being sort of out here is a better option. Our brain's sort of like, oh yeah, I remember that. Are we alive?
No.
Do we speak?
No.
Oh, this is gonna be an interesting trimester. Maddie, you speak? Not first period. Okay, what's another way we could find slope? Sherry, you started saying it. What was the next way we could find slope? Right, a formula. What letter do we use to represent slope? M. So maybe we're given two ordered pairs of 2, -3 and 2, 7. Maybe we're not given ordered pairs. Maybe we're given a graph, but you prefer to name those ordered pairs. Right? Functions can be represented in all different forms, so that's okay. So now we have these 2 points. What are we going to do to find the slope? Lizzie, what are we going to do?
7 - -3
Right? Because this is an x, y. And that little tiny number underneath, okay, the subscript identifies that it's our first ordered pair and our second ordered pair. And we sort of plug those numbers in where they go. So what is 7 minus -3? 10. And what is 2 minus 2? 0. Okay, so here's a tricky one. What does 10 over 0 reduce to? Nope.
1.
Nope.
10.
Nope. Elena? We're getting really close, but this isn't an equal sign, so not no solution. So do you want to pick a different word, Elena?
No. All.
Nope. Nope. Undefined. Undefined. What does undefined slope look like? Okay, right? So my students would equate this to death. If we're skiing, I cannot ski. Okay? I have no coordination. I will trip 42 times while I'm teaching. Okay? And I'm walking on flat ground. Welcome to my world. I can't ski. But let's just pretend that you were a skilled skier. Pretend I'm skilled. And if there's a steep slope, okay, great. But undefined slope looks like a vertical, it doesn't look, it is a vertical line. How's that gonna go for me? I am going off the cliff, right? Death. You can't ski on it, it's not possible, it is undefined. If you put 10 divided by 0 in your calculator, it'll say error. If I have nothing, I'm broke, can I share it with 10 people? Nope, I got nothing to share. It is undefined. Okay, so this one is undefined. Are we okay there? What happens if 0 is on top? What does that simplify to? Nope. Nope. You guys are thinking equal signs. Those are like, what does x equals? 0, right? So 0 on top is 0. If I have $10, can I share it with nobody? Yes, sure can. I do it every day. Right? I got money. I'm not giving it to you all. Right? Are we okay there? Remember, slope goes into reduced improper fraction form. So no decimals. Who's team decimal? Hashtag team decimal. We got a few of those in here. Yep, no more decimals, right? Reduced improper fraction form is the only thing slope can go in. Anybody remember how else we found slope? Oh, there goes Amari to notes. What do we got, Amari? What's it say at the top? At the very top, rise over run. We got the formula. What's the third one? I think. What is yours saying, Anthony?
Rate of change.
Oh, rate of change gets the label. Change in y over what, Maddie?
Change in x.
Right, so all of that is sort of the same, right? We have this change in y. Does it matter which way you think about slope? Whether you think rise over run, whether you think change in y over change, does any of that matter? No, right? So again, I'm just giving a third representation here. It doesn't mean that this is the only time you can use it. We're gonna stick simple because it's Monday morning and my brain isn't thinking yet. thing? Lizzie, what do you think?
Take two of the groups.
Which two do you want, Lizzie?
The biggest one.
Oh, you're a Mr. O'Neiller, aren't you? You had Mr. O'Neill last trimester? Mr. O'Neill loves the bottom of the table. I don't know why. Mr. O'Neill's a bottom table lover. I'm a top table lover. One is not good or bad. I would pick 6 and 12 and 7, 14 because they're smaller numbers. I don't know. Mr. O'Neill likes to pick, whoops. Okay, so we could choose to write these as ordered pairs, and we could find slope there, keeping in mind that this would be 18 minus 16. So what is 18 minus 16? 2. And what is 9 minus 8?
What? 1, 2.
Now, you can a lot of my students will just like to rewrite it here and go 18 minus 16 over 9 minus 8. It's the exact same thing. It's fine. Does that sort of remind us about ways we can find slope? So that's going to be the major chunk of your quiz on Wednesday. You can use notes on your quiz, right? Just like any quiz, you can use notes, so you'll be able to use these, right? Then you're going to have 2 that are standard form. So standard form for all my students, they gave me the stink eye. They were very not happy with me that I taught them functions before I taught them standard form. But if I give you an equation like (6x minus 2y equals 18), what 2 things can we find in standard form? Lizzie, what do you say?
Subtract the 6 off the side.
That's if we want to solve for y, which we could do, and we're going to talk about when and how that is more useful. But there are 2 specific things we could find in standard form where we didn't have to solve for y. Do you remember what they are, Elena?
Don't you subtract 6x and then put 6x?
No, that's still solving for y. That's still solving, but that's the same idea. How about the idea of finding an x-intercept and a y-intercept? Is that ringing a bell? Uh-oh. What is an x-intercept? What is this again even talking about? What is that word mean? What does it mean? Oh, Margie knows. What's an x-intercept?
It touches.
I was just gonna say, don't you just add 0 in?
Yes. Yup. Okay, so hold that thought for a moment. What is an x-intercept?
I don't think it's equal to that.
Keep going, Margie.
A third of the point, that's like whatever the point is on like the x.
Right, and so it's where the graph is touching the x-axis. Right, whether it's going, a line is going to intersect it, it's going to go all the way through. Okay, we'll look at graphs later in the year at the very end where it just touches it, but it's where we are touching the x-axis. So I have this as a line. Where is my x-intercept at?
On top.
Right here?
Yeah.
Okay. Well, I'm looking at a random graph. I have no idea what these points are, but what do we know is true of the y value right here? It's
0.
0. X is some number. The y value is 0. Okay, so we can plug in 0 for y. Now, when we plug in 0 for y, what is 0 times anything? 0. So that makes this just go away. And we're left with an equation that says 6x equals 18. How do I solve that? Divide by 6. So what does my x-intercept equal?
3.
3. And we just know, because I'm talking about an x-intercept, that that is really the ordered pair 3, 0. right? We don't say it because we know an x-intercept always has a y value of 0. Okay? Let's get a different color. So if I want to find the y-intercept, this point down here, what is my x value going to equal? Because this is 0 comma y, right? So I'm plugging in a 0 for x, and 0 times anything is 0, so I'm left with negative 2y equals 18.
Divide by negative 2, get negative 9.
Right, so we'll divide by negative 2, so my y-intercept is negative 9. How do I graph that?
Negative 9, 3
Negative 9 where?
on the y.
On the y-intercept.
3 negative 9.
Okay, so negative 9 on the y-intercept because I know this is really the point 0 comma negative 9. And where am I putting this? On the x. And there's my line. Now, could we have solved it for y, made a table, plugged in 3 input values, got their corresponding output values, plotted those points, and then got the exact same line? Sure. But that's a lot of work. Okay, it's definitely more work. This is way simpler. How do we feel about that? Okay, so in here I'll do a lot of judgment calls with thumbs up or thumbs down. So these are the 3 options that you get.